Hello everyone, so this is going to be the second part of the Unit 2 practice test where we'll go over the short answers and also the problems. So question number 16, the graph of y equals g of x is translated 5 units right and 7 units up. So that means that we have the c value of 5 and the d value of 7. So continuing to use the format y equals to a and then f of b and then x minus c plus d. In this case, we'll have the answer y equals to g of x minus 5 and then plus 7. Okay, number 17. The point A with coordinates -6, -8 lies on the graph of y equals f of x. So we're looking for the image A prime on the graph of y minus 4 is equal to f of x plus 3. So in this case, we have d is equal to 4 and c is equal to -3. So that means we are moving up 4 and also left 3 spaces. So the point A, which starts at -6, -8, going towards A prime, would be -6 minus 3 because of the left 3 translation, and then -8 plus 5 to move the point up 5 spaces. So when we combine, oh, sorry, not 5. Why did I think it's 5? It's 4. Sorry about that, folks. So this is a 4. This is also a 4. All right, so A prime then is going to be -9 and then -4. Okay, so number 18. Equation of the image of y equals to the square root of x plus 4 after a reflection in the y-axis. So in this case, we are looking at y is equal to f of -x. So we simply replace all instances of x in the function with -x, which will give us, in this case, y is equal to -x plus 4, and then that is square rooted. Okay, moving on to number 19. The graph of g of x is the image of the graph y equals f of x after a stretch or compression and a pair of translations. So the corresponding points are once again indicated. We are to describe the transformation. So the points in the original f of x were 0, 0, and 4, 2. And the new graph, we have the points -3, -2, and also 1, 2. Okay. So the point going from 0, 0 to -3, -2 tells us that 2 of the transformations were left 3 and also down 2. Notice that in the question, it's going to use a different color here. The horizontal spaces is 4 in both parts, both in g of x and also in f of x. So there's no horizontal stretches in the function. However, vertically, the points used to have 2 spaces between them. Now there are 4 spaces between them, which means the graph underwent a vertical stretch by a factor of 2. Okay. So vertical stretch by 2. And those are the 3 transformations. So it just says to describe the transformation. If we were to write g of x as transformations of f of x, then it would have been y equals to 2 f of x plus 3 and then minus 2. Okay, so that's number 19. Let's move on to the problems. Number 20. Okay, so here's the graph of y equals f of x. In the same grid, sketch the graph of y plus 4 is equal to f of x plus 4. Describe how the graph was translated and state the domain and range. So the original f of x, and the graph was already drawn, but it would be a good idea to indicate what transformations there were. So the 2 transformations, one was due to d equals -4, and the other one was due to c being -4. So the transformations were down 4 spaces and also left 4 spaces, which is what the graph in red was about. So the other piece is the domain and range, of course. So the domain of the original y equals f of x, the domain is all real numbers. The range is that y is less than or equal to 0, just by observing the graph of y equals f of x. The assumption here is that it continues onwards. Afterwards, we have the transform graph y plus 4 is equal to f of x plus 4. So the domain does not change because of the translation, but the range does. The graph was moved down 4 spaces, so the range will now be y is less than or equal to -4. Okay, and that's it. So number 21. Right, so again, we had the graph drawn already. The graph of y equals f of x was given. On the same grid, sketch the graph of y equals to negative f of x. So here, the easiest way to think about this question is simply this negative sign indicates to us that we have negative y values instead of the positive ones, and the positive y values would have become negative if there were any on the graph. So in the graph, we have the points, say for example, -1, 1. So in the transform graph, we will have -1, -1. Likewise, for the point here, this would be 0, 3. After the transformation, this would be 0, -3. And one more. So here, for example, this was -2, 3 was the original point. And after the transformation, this would be -2, -3. So this is how the graph was actually produced. Okay. And that will be very similar to number 20. We can select points with integer values and then simply apply the transformations to them and produce the image graph. So going back for a second here, for example, this would be the point 2, 0. So after the transformation, we subtract 4 from both the x and y values. So this will give us -2, -4, a corresponding point on the new graph. So that's the idea. Let's move on to number 22. Here's the graph of y equals f of x. On the same grid, sketch a graph of y equals 2f of 2x, state the domain and range of the image only. All right. So let's look at some points on the original graph. So here we have, for example, the point -2, -4. We also have the point 4, -2. And finally, the point 6, 2. So let's consider what the 2, both outside of function and inside of it, does. This 2 here indicates to us there is a vertical stretch by 2. And the second 2 is a horizontal stretch, but by half. So essentially, the x values on the points will be halved, and the y values will be doubled. So for example, the point -2, -4 will halve the x value, which gives us -1, and double the y value, which gives us -8. So the corresponding point would be here. And that's, once again, -1, -8. Likewise, with the second point, going from left to right, 4, -2. Again, we halve the x value, so it will become 2. And then we double the y value, which becomes -4. So the second point will be in this location. And finally, the third point, 6, 2. Again, we halve the x value, so we get 3. And then we double the y value, so we get a point 3, 4. Okay. And once we have those 3 points, we can connect them together. Very similar way to the original function. Sorry about that. It's a bit better. This point here. So the function will be, the range will be twice as much, and the domain will be half as much as what it was before. Okay, so the domain and range of this new function would be going from -1 to +3, and then the range would be going from -8 to +4. Okay, so one more question, number 23. We're given the graph of y equals f of x, and then we have a bunch of transformations, and then it asks to write the equation of the image graph and then sketch the graph and then state the domain and range. All right, quite a lot to do. So let's start by finding all the transformation. The first one was a vertical stretch by 2, and then is followed by a horizontal stretch by 1/2. And then afterwards, there is a reflection in the x-axis, followed by 2 translations. So one that is horizontal, 3 units to the right, and finally the last one, which is 2 units down, sorry. All right, so let's write an equation. So we have y equals 2. Let's talk about the reflection first. The reflection will cause there to be a negative sign in front of the a, and the value of a is actually going to be 2. Okay, let's try this again. Let's do this. Okay, so let's try to color match the transformation as we move from left to right in the function. So -2, and then f of, and then the b value is going to be 1/2. Oh, sorry, the b value would be 2. The stretch was by 1/2, so the b value is 2. Right. And then finally the translation, 3 units right, that would be -3. Like so. and then 2 units down, so that would be minus 2. Oh, sorry, I forgot a parenthesis here. The minus 2. Okay, so to summarize, starting with the negative sign, that is a reflection in the x-axis, followed by the 2 in red, which is a vertical stretch by a factor of 2, followed by the 2, which is in this light orange color. That's a horizontal stretch by half. Again, we take the reciprocal of the stretch. Followed by 3, the minus 3, which is a translation to the right, and finally the minus 2 outside, which is 2 units down. Okay? So that's the first part, is to write the equation. The second part is to produce the graph. The graph is drawn already. So let's look at how we got from the original to the image. So this is, oops, sorry about that. I want to use the other color here. So this would be 0, 0, again 4, 2. This is, of course, the square root function, and 9, 3. So consider what happens. The point 0, 0 it's not going to be reflected or stretched because those are multiplicative transformations. So the only transformation that affects 0, 0 will be the translation, and that is 3 to the right and down 2. So this is how we got the point 3, negative 2. And from there, we also have the second point, which is 4, 2. So the point 4, 2 will undergo the transformations. It will be vertically stretched by 2, so 4, 4. Horizontally stretched by half, which gives us 2, 4. And then the reflection gives us 2, negative 4. And then we move it right 3, which is going to give us 5, 4. And finally down, 5, negative 4, and finally down 2, so 5, negative 6. Just to talk about the thought process, this could also be written down if we were doing this question in more detail. So, and then finally the last point here will be 7 and a half, and then negative 8. Right, so we're just gonna use the 0.93 as an example. So here, after the a value is applied, we'll have the point 9, negative 6. After the b value is applied, we'll have 4.5, negative 6. After the c value is applied, we'll have 7.5, negative 6. And finally, after the d value is applied, we'll have 7.5, and then negative 8. So that will be a better indicator of the thought process used to generate the points. And finally, the domain range of this, the domain is going to be x is greater than or equal to 3, and the range is going to be y is less than or equal to negative 2. And so that's it. So that's the entirety of the Unit 2 practice test. Once again, thank you for listening.